Branch per feature. So right before lecture, there was a student who was asking me about this. And so I'm going to preface this by saying that this is a highly opinionated part of my class presentation. There are many different schools of thought about how to do development as a team using Git and branches. I'm not going to say that any of those approaches is wrong, but our experience has been that in a class setting like this, with teams that are maybe not quite as experienced as a team that's been in industry for several years, we really recommend that you do it this way. We think it will be less pain. But I am not saying that this is the one and only true way to manage work as a team with Git branches. And I will talk about at least one of the alternatives, which some people call trunk-based development. So what does branch per feature mean? It's pretty simple. As you're probably aware, when you start a new repo, the sort of default branch on that repo is called the master branch. But at any time, you can create a sub-branch off of it. And you can even create branches off of the branches, although the graph gets pretty hairy pretty fast. If you've tried doing this, you probably have seen that creating a branch is basically free. Like, it doesn't take any time at all. Unlike, for example, forking a repo, which takes up to a minute. But creating branches is free. Switching between branches is really easy. Every branch has its own commit history. So branches, once you have created the branch, anything you do there is invisible to any other branches until you somehow do a merge operation, or by deciding that that branch is going to die and those changes won't go anywhere. The methodology that we recommend for small teams working with a single repo is branch per feature, deploy from master. So roughly speaking, what that means is when you're going to create a new feature that's a programmer or a pair of programmers, you immediately do a branch off of master. You limit your work on the feature to that branch. And using one of a couple of different mechanisms that we'll discuss in a moment, you eventually get those changes back into master, and you maintain the invariant that at any time it is always safe to deploy from the head of master. That gives you sort of a stable point. So if something goes horribly wrong, or if some code that you put into a feature branch doesn't quite work, maintaining the invariant that master is always safe. And one of the reasons that we really want teams to be using Travis and code coverage and things like that is then you get instant feedback, right? If you break master, you'll know it right away. There's also an additional layer of safety, if you want, is that you can use a release branch. So this sort of adds a layer of insulation, which is when you're getting ready to do a release, rather than releasing from master, you first do a branch off of master, and then you use that branch as the release point. Because that way, even if you manage to screw up master, if you violate the invariant that is always safe to deploy from master, you still have the tip of the release branch, and you know that's safe because that's where you deployed from, right? And you can roll back to earlier releases that way as well. So what does this workflow sort of look like in practice? You create a new branch just for the feature. And in my book, and when I say this, this is how I personally do my development. There is no such thing as a feature that is too small to deserve its own branch. Even if that feature is just going to be like making a simple change to a view, or adding a filter to a controller method, even if I think it's going to be just 1 or 2 lines of code, make a branch, because there's no cost to making a branch. Which means, of course, a lot of features can be in progress at the same time. The second thing, and this is really important, on that branch, only do the things for that feature. Don't do anything else. So you started your branch, you started your feature, and you realize there's a typo or a bug or just something that looks ugly somewhere in the code. It's oh, while I'm here, let me just fix that. Resist the temptation to do that, because one of the reasons to do branch per feature is that it makes it somewhat easier to isolate the changes related to one specific thing. If you later need to undo the merge of that feature, you don't want to take with it other cool stuff that you did in the branch that actually have little to do with the feature. Which means that backing out a feature, for the most part, is undoing a branch merge, which isn't trivial, but it's actually not the most painful thing in the world. So keeping the branch only for the changes needed for that feature. And the rationale is that if your app is reasonably well factored, conflicts when you do this should be relatively rare. And we'll talk about how to deal with conflicts in just a moment. So in my hypothetical diagram, the master is this kind of middle horizontal line. Amy, Bob, and Dee have all started feature branches because they're working on 3 different features. Bob runs into some trouble and decides his feature is actually not going to work out, so he just lets his branch die. You can let a branch never be merged back and just say delete it. This experiment failed. Amy is the first to actually finish her feature, and she will eventually cause her features changes from the branch to be merged back to master. That's great. When it's time for D to merge features, there's a possibility that some of the files touched by D's commits may also have been modified as part of Amy's commits. Now again, in a well-factored app, it should be relatively rare that the same lines of the same files are modified, because that suggests that Amy's feature and D's feature were maybe not as separable as they thought. But in the normal case, even if there aren't going to be hard conflicts, D may be required to essentially do an update and get the latest version of master in her repo before it's possible to clean up the merge. So we'll talk about different strategies for doing a merge, but the message here is if you're trying to do a git push and you get this message that says there are non-fast forward references and you have to do a git pull, it doesn't necessarily mean that you're going to have to resolve a merge conflict manually. It just means that there are some commits present in the branch into which you're trying to merge that are absent from your branch. So something has changed out from under you since the time that you did your branch. You need to make sure that you have the latest version of the branch you're merging into. And then as you continue the merge, you can see whether, in fact, there were conflicts that require manual resolution. And we'll talk about how that's done. So by the way, what is if you don't do branch per feature, what is the alternative to doing something like this? Some people call it trunk-based development. And basically what it means is no branches ever. So when you make a code change and you commit, you're committing to master. And ideally, there's some place from which it is always safe to deploy. You could be saying that it's still the head of master. You could be using release branches where when master reaches a point everyone agrees is stable, at that point you create a branch and say, OK, we're going to release from here so that as we continue to change master, at least we have a safe place to go back to. We know that if we have to fix the deployment, we can always go back from here. So there's this question. And by the way, Facebook is known to use this development model. Facebook, at least as of last year, they used a model where commits generally go to the master branch. I'm not going to say that that's a wrong way to run a business, because Facebook's doing OK. But I do think that you have to have safeguards in place somewhere to make sure that when things are committed to master, stuff is not breaking. Now, one place to have those safeguards is you're doing your development on a branch. You can break stuff on your branch, and that's fine, as long as before you try to merge anything back to master, you fix stuff on your branch. If you're not using branches to have that isolation, what safeguards do you have to make sure that when you commit to master, you're not stomping on something important or breaking something important, right? And at a large, sophisticated company, there are many such safeguards. Google has all kinds of safeguards in place before your commit is even allowed to happen. And those safeguards include test-related things, code style-related things, human beings signing off related things. So yeah, you are committing to master instead of doing a branch, but the process of committing to master itself has a bunch of safeguards built in. Because I don't think it's practical in this kind of a class setting to do that, our high recommendation is to use branch per feature. It's not a magic wand, it's not a panacea, but it saves you from certain kinds of pain. So I'm going to continue on the assumption that most of your teams are probably going to use branch per feature or something like it, and talk about what the pitfalls are of how you might accidentally misuse it. So what are the mechanics? Pretty simple. You create a new branch and you switch to it. You make your commits, et cetera, on the branch if you're working with a pair. You might be pushing the branch periodically back to the origin repo. GitHub is a great place to back up your stuff. Plus, you can have it configured so that when you push a branch, it'll run the regression tests on your branch, and you'll know if you broke something. Now, at this point, if you're working solo, if you're working not in a team, most of the time, when you get to the point where your branch is ready to be integrated, the next step would be you go back to master and you say, merge my branch, right? Something like that. If you're working in a team, though, this is not necessarily the best way to do it for a couple of different reasons. First of all, using the diagram from the previous slide, if you're doing a merge, and since the time you began your branch, other things have happened on master, there's a good possibility that doing that merge is going to require you to resolve some sort of conflicts. Maybe it's just sort of verifying that the conflicts aren't like the same line of the same file, but something will happen, right? So as a human being, you're going to have to look at the code and say, OK, even though things have changed out from under me on master, I'm confident that the merge is not going to break anything. And this, in some sense, this puts the onus on whoever is keeping track of having a clean master to do this. So the alternative is to do a rebase instead. And this is the mechanism that we'd recommend you use. So essentially, to rebase a branch against some other branch essentially means try to pretend that it was branched from that commit. So here's an example where just after the very top commit, a branch was created. Some commits have happened on this branch. And in the meantime, other commits have happened on master, probably as the result of merging other features. So now, if at this point we were to say, try to merge this branch back into master, the changes that we made and the changes that were made here are going to require some resolution. Maybe there won't be any hard conflicts, right? That could happen. But something about the fact that master changed out from under you is going to have to be dealt with by someone. So a way to do that sort of takes the burden off of whoever is in charge of keeping an eye on master is say, at this point, I would like to rebase against the master branch. What that means is, originally master was there when I branched. Now master is in this state. What happens if I essentially try to put my work aside and replay it on top of this commit? And in many cases, in a well-factored project, it'll just work, right? Whatever these changes are may have nothing to do with the changes you made. So you're basically going to say, I've got these changes. Now I'm going to replay my commits on top of them, and maybe no manual conflicts will happen. If manual conflicts do happen, you still have to fix them. But now, in some sense, the onus is on you to fix them. Because if you rebase against here and you fix all the conflicts, what that means is that now you're in a position where if you do a merge, the merge is clean, right? You're guaranteed that, unless, of course, it takes you so long to do the fixes that in the meantime, more changes happen on master. But we hope that's not the case. Right? So rebase is basically saying, as the branch owner, I'm going to take responsibility for making sure that when we merge to master, it's totally clean. And the way I'm going to do that is I'm going to first rebase against the latest master, do any cleanup that's necessary there so that by the time my rebase is finished, it's guaranteed that if I then merge to master, the merge will just work. Because it's as if I had branched from here, made my changes, and then immediately merged them back. Right? And by the way, rebases can be complicated. If it turns out you have a lot of conflicts, you're sort of going to be in this limbo state of rebasing for a while. But you can abort a rebase. You can say, oh my God, stop this and go back to the way my branch was before I began trying to rebase. You can try to manually do some fix-ups and then try rebasing again. But in all that time, you haven't screwed up master, and that's really important. So it helps maintain this invariant that the tip of master is always a good place to deploy from. Once you resolve the merge conflicts, then should you actually merge to master? I would say no. Because if you're working with a team, part of the benefit is having other people kind of look at your code with another pair of eyeballs, not only to find mistakes, but also maybe to catch things that you might have done a little more elegantly or something. So instead of doing the merge, you do a pull request, which is basically, excuse me, basically is a way of saying, I would like to merge my commits from the branch back into master. And if you've used the pull request review mode in GitHub, it's really nice. You can see the differences between the files in different colors. You can attach comments to like specific lines of a file. So the pull request really is almost like a miniature form of code review, which I'll talk about more in a moment. But the expectation is that when you make a pull request, you're making it against a branch that has already been rebased. So accepting the pull request is guaranteed not going to cause a conflict. So the only thing the pull request is there to do is essentially make a public announcement to your team, hey, I want to contribute this code. I would like everybody else to take a look at it before I do that.